Welcome to Mission Control. I'm your flight director for today's explainer, and we are cracking the code on one of the absolute most misunderstood systems in Cambridge mathematics, Module 1.2 functions. Look, if you've been treating your past papers like simple math quizzes, it is time to seriously upgrade your approach. Today, we are acting as systems engineers. We are treating this exam paper like a strict, structured aerospace mission. On the main console screen right now, we have our objective, a multi-part past paper question. And to help us out, I'm tracking the telemetry of two student pilots today. We've got pilot Alex, who constantly overcomplicates data calculations and burns way too much exam time and fuel. And we've got pilot Sam, who just completely ignores structural boundary constraints, risking total systemic breakdown. We are going to map out the exact telemetry examiners use to grade your papers, so you don't make their mistakes. Let's initiate launch sequence.
So I want you to really think about this question on the screen. Why do so many students fail when the context is unfamiliar? Well, principal examiners repeatedly report that translating theoretical math to unfamiliar, real-world scenarios is literally where you lose the most marks. It's like having a perfectly built rocket, but absolutely no idea how to adjust the flight path when the atmospheric pressure changes. Pilot Alex knows the formulas, right? But when Cambridge introduces a variable Alex has never seen before, the whole system breaks down. And Sam just punches in numbers without checking if the environment can even support them.
All right, here is our flight plan for today. 1. The function's dilemma. 2. Core concepts and our memory hack. 3. The method mark strategy. 4. The top 3 examiner traps. And 5. Your exam execution plan. Let's move.
Section 1. The function's dilemma, moving beyond rote memorization. Okay, Cambridge's assessment framework prioritizes analytical depth over superficial breadth. What this beautifully illustrates is that simply memorizing math formulas isn't going to get you into orbit. You need to demonstrate logical, structured reasoning. When you encounter a bizarre word problem about a function modeling, say, a physical boundary, you can't just be like Pilot Sam and plug in numbers blindly. You have to understand the fundamental principles well enough to transfer them to literally any scenario.
Moving to Section 2, Core Concepts and our memory hack, the 5 pillars.
We can organize the fundamental concepts of Module 1.2 into a highly reliable high-tech instrument panel for your exam. These are your primary targets, your 5 pillars. I'm pulling up the UI console overlay right now, and let's look at how our pilots are doing. Domain and range dictate the operational boundaries of your function. Sam completely missed this and is trying to fly outside the domain. 1-1 and inverse functions are your trajectory checks, meaning is the path reversible? And composition is how you link multiple systems together safely without crashing. You absolutely have to master identifying these relationships. To lock this in, we use the memory hack DROIC. That's the first letters of domain, range, 1-1, inverse, and composition. I want you to write this acronym at the top of your paper the second you sit down for the exam, so you never blank under pressure. When you see a functions question, run down the DROIC pre-launch checklist. Have I defined the boundaries? Is it a 1-1 relationship? It's your ultimate safety protocol. All right, Section 3, the method mark strategy, earning points for process. Okay, hold up. I'm actually pausing this simulation right here. Before we fire the secondary boosters to secure those maximum marks, you need to optimize your own flight path. Take a second, subscribe to AC Exams at the handle @AC Exams right now, and turn on all notifications so you never miss a critical mission update. Okay, simulation resumed. This is where you learned to squeeze every possible point out of the grading rubric. Examiners are tracking your systematic processing just as much as your final number. Pilot Alex calculated the perfect trajectory, but because Alex didn't show mission control the math, the work is invalid. 0 method marks. Now, I'm looking at the radar, and our crew has just hit a critical roadblock mid-paragraph. Their evidence links are completely failing. So as flight director, I am overriding the console and injecting a structural template to save their trajectory. Every time you tackle a function, follow this automated launch sequence. 1. Identify the key elements, the parameters of the problem. 2. Apply relevant principles, your DROIC checklist. 3. Execute your analysis clearly. 4. Verify and evaluate your results to ensure they fit system constraints. And 5. Present your final format, linking it back to the context. That sequence right there is how you survive a system failure. And this brilliantly illustrates why you must follow strict conventions. Clear annotation and correct terminology are absolute, non-negotiable requirements for full marks. If you use the wrong bracket for a domain interval or you mislabel an inverse function, you are literally leaking fuel, leaking marks. Structural compliance is mandatory to keep the ship intact. Pushing into Section 4, top 3 examiner traps.
What principal examiners warn against.
Okay, listen up, because we are entering a live, interactive viewer radar challenge. We are heading straight into the danger zone, pulling directly from Cambridge Principal Examiner reports. There are exactly 3 major repeating debris fields that derail students. For Simulation 1, I'm putting a 60-second visual countdown clock on your screen. Imagine a highly complex source graph right in front of you. Can you locate the hidden core variable before time runs out? Most students can't because they fall into one of these 3 traps. Let's clear the debris. Here is the debris on our radar. Rank 1, confusing cause and effect. This means fundamentally misunderstanding independent versus dependent variables, which completely fails your application and analysis marks. Rank 2, forgetting to check presentation conventions, which we just discussed. And rank 3, the absolute biggest threat out there, answers not specific to the context. This shows a complete lack of analytical depth. All right, Simulation 2, debris detection. I want you to identify the specific sentence where a sample student answer falls below compliance standards. Look at the generic answer versus the context-specific one. The generic answer is the debris. For instance, if the function calculates the temperature of a chemical reaction over time, your domain constraint isn't just x is greater than 0, it is time cannot be negative within the context of this experiment. You must speak the language of the specific problem. Sam tried to use the generic answer and almost blew the whole mission.
Final phase, Section 5, your exam execution plan, bringing it all together.
We have done the pre-launch checks, we navigated the debris, and I am confirming a successful, full-mark touchdown sequence for Pilot Alex and Pilot Sam. Amazing! So let's distill this into your pre-flight question scan checklist. When you sit down for the test, your execution plan must be to deconstruct the question, extract only relevant data, select your analytical framework using DROIC, execute the math with clear notation, and present it using perfectly compliant terminology.
If you take absolutely nothing else away from this mission, let it be this massive examiner alert straight from mission control. Always link every point to the given scenario. A function without context is just an abstract string of numbers floating in space. To secure top-tier marks, you must prove you understand why the function behaves the way it does within the boundaries set by the examiner. So, I leave you with this final thought before we log off. Will you approach your next past paper as just a mathematician trying to find a simple answer, or will you approach it as an elite examiner masterfully executing a flawless, verifiable process? Practice your past paper questions using this precise simulation framework. Finally, to optimize your future flight paths, subscribe to Ace the Exams at @AceTheExams, hit that notification bell, and drop a comment down below right now sharing your specific subject and tier. Lock down your strategy, and I will see you on the next mission.